Alright, dudes and dudettes, here we go with 4.1, using graphs to relate two quantities. After this lesson, I'll be able to represent mathematical relationships using a graph. Stop. Make sure your volume's on. There's lots of little things here that you won't pick up just from the writing. So please make sure you listen to the video as well as watch it. Alright, here we go. The graphs below show the height of the water to the volume of the water in each container. Which graph represents which container? Alright, so here's what I have here. My first graph, the volumes are down here on the x-axis. The heights are over here. So we're comparing the volume and the height. Alright, so in the first graph it goes up and then it kind of levels off. Here in number 2 it goes up slowly, it looks like, and here in number 3 it goes up quickly. So these are your three containers. So my job is to match the container with the graph. Alright, a couple things to think about. Please make sure you jot these down on your note sheet. So if each of the first two containers holds the same amount of water, which container would have the greater water height? Alright, so both of these have the same amount of water in them. Alright, which one would have a higher height? Alright, hopefully you would think it would be this one, because this one will rise up faster because it's skinnier. Okay. Number 2, does a constant increase in volume result in a constant increase in water height in the first container? So if I keep pouring water in here, am I going to consistently get higher? I would say yes. If I'm going to pour water into this one, am I going to consistently get higher? I would say yes. If I do it in the third one, will I consistently get higher? Alright, consistently. So as I fill this up, yes, it would continue to grow at the same rate, but then as soon as I get into this cone looking thing, it's going to change how fast it goes up. Alright, because this cone holds a little bit more than this bottom cylinder part. Okay, so how does that help us? How is a constant increase indicated on a graph? Well, constant is the key word here. So anytime I have a consistent increase or consistent decrease, my graph is going to be linear. It's going to be a line, like here in number 2 or number 3. All right, so if we go to match them up, that first graph goes with this third container. Goes up pretty quick, and then it starts to level out. As I keep pouring water in here, the height isn't going to go up as fast because I have a wider diameter here. So it's actually going to kind of level off. All right. Graph number 2 goes with container number 1. Because as you pour more water in, the volume is increasing and the height is increasing, but since it's so wide, it won't go up as fast. And then therefore graph number 3, this one, goes with container number 2. Imagine pouring the water in there and it's filling up fast. It's going up fast. That's what it shows you in graph number 3. So notice these two have a constant rate of change. They represent these two cylinders. Okay? All right, good. So here's our essential learning. For 4.1, you can use graphs to visually represent the relationship between two variable quantities as they both change. So here we go. The graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Describe how the variables are related at various points on the graph. So I see time, volume. Title on my graph is the air in the balloon. All right, so my variables are the time and the volume. All right, how are they related? The volume of the balloon depends on the time. All right, so the volume is changing in the graph. Okay, the volume changes as the time passes on. So as the time is going on from left to right, the volume is doing different things. Okay, so the volume increases or goes up each time you blow into the balloon. All right, so let's look at spots on the graph. See, it's increasing when you blow into the balloon. It's increasing when you blow into the balloon. It's increasing when you blow into the balloon. And then it increases here for a little bit. We'll talk about that spot here in a second. All right. Now, in between times you blow up the balloon, you have to catch your breath. So the volume stays the same as you pause to breathe. The horizontal portions of the graph, these spots right here, are when the volume is not increasing. It's not going anywhere, but the time is still going on. So imagine you blow into the balloon and then catch your breath for a second. Blow into the balloon, catch your breath for a second. Blow into the balloon, catch your breath for a second. All right? So that's what's going on in those two parts. And then the balloon pops in the middle of the fourth breath. So that was 1, breathe, 2, breathe, 3, breathe. And then I start to blow in at that fourth time. And then all of a sudden, the graph stops and then shoots straight down. So the balloon pops in the middle of the fourth breath. The volume quickly goes down to 0. So at that spot right there is where the balloon broke. I was breathing into it, and then a boop, and then it quickly shot down back here to volume of 0. Okay? What are the graphs in this? What are the variables in this graph? Describe how the variables are related at various points on the graph. Okay, so it looks like this. All right, this is a strange little thing going on. It's the board length. So imagine a piece of wood. As time goes on, the length changes. All right, so my variables are the time and the length of the board. The length of the board depends on the time. So as the time changes, the length changes. All right, the board is a certain length, and then it is cut and gets shorter. So the board's going along being a certain length, and then all of a sudden, right there, beep, the guy cuts it. So now instead of being whatever you want this to be, 5 feet, he cuts it, and now it's this many feet. All right, so then it stays that size for a while, and then all of a sudden, right there, the dude cuts it again. Weep. All right, and then it stays that size for a while, and then weep, right there, it gets cut again. Deep, and then it stays the same for the rest. Okay, so the key is horizontal parts are where it's staying the same, all right, and then it jumps down to that next horizontal part, jumps down to that next horizontal part, jumps down to the next horizontal part. Okay, so you should be able to kind of describe what's going on with the graph. What are the variables in the graph? Describe how the variables are related at various points in the graph. June cell phone cost, number of minutes, cost. All right, so my variables are the number of calls and the cost. All right, the cost depends on the number of minutes. All right, so this cost is changing based on the number of minutes. Sometimes it's staying the same, sometimes it's changing. Cost stays the same for a certain number of minutes. The cell phone plan provides for a set number of minutes for a fixed price. So it's like, oh, you get 500 minutes or something. So, okay, so that stays the same. And then as soon as I get past that 500 minutes, so at all these spots, it's staying the same. And then I reach my limit to my plan. So let's say it was 500 minutes. So I'm 500 minutes, beep. And then as soon as I get to that 501st minute, they start to charge me extra per minute. So then after the fixed number of minutes is used up, which happens right there, the price increases per minute. So that's what's going on this spot of the graph. All right, so imagine your cell phone plan. You get 500 minutes, and then every additional minute is 5 cents or something like that. Okay, so that's what the graph would look like. Very nice. Tables and graphs can both show relationships between variables. Data from a table are often displayed using a graph to visually represent the relationship. So sometimes it's easier to see a picture of what's going on than it is to just look at a table or an equation. All right, let's take a look. A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? All right, so I have 4 choices. They gave me the table. All right, so day 1 is this many, day 2 is that many, day 3 is that many, day 4 is that many. Okay, so a couple things to think about. Should the horizontal distance between the points be constant? So if you look at all these pictures, the horizontal axis, this side-to-side axis, is all the days. Right? Now if you look at your table, it's consistently changing. 1, 2, 3, 4. So should the horizontal distance between the points be constant, stay the same? It should, because each time it goes by 1, it is consistent there. All right, what about the vertical distance? So vertical is the total downloads, total downloads, total downloads. So if I look in this column, well, does that stay consistent? From here to here, and then from there to there, and then from there to there. Does that look consistent? Well, from here to here is about 700-ish, right? From here to here is about 2,400. And then from there to there is about 7,000. So it's obviously not staying the same. So it shouldn't be constant. The distance vertically should not be constant. All right? And then as I follow the graph from left to right, should it go up or down? Well, as I get more days, I'm getting more downloads. So it should go up, all right, from left to right. As the number of days increases, so does the number of total downloads. So from left to right, I'm getting more days. And according to the table, I'm getting more downloads. So let's start to eliminate some of these choices. Well, it can't be this one, because this one's going down. This tells me the more days, the less downloads. And that's just not true from the table. All right, what else do we know? Well, it's not that one. Because here, it would tell me that they consistently get the same number of downloads each day, which isn't true. Here, the vertical change from here to here, here to here, here to here is staying the same. And it shouldn't, because these numbers here are not consistently apart, right? Again, this is like 700, this is like 2,400, this is like 7,000. So that's changing. So now we're down to one of these two, B or C. Well, it's not C, because if you look at C, what's going on? Well, it's going up, 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 that's great, but then it starts to level out, when in actuality it should be getting bigger. From day 1 to 2 is a smaller change than from 2 to 3, which is even smaller than from 3 to 4. So the jump from 1 to 2, from 2 to 3, and from 3 to 4 should be increasing, which is what happens in this picture, not in that picture. So correct choice B. All right, cool. Which graph could represent the data shown in the table? All right, so they gave me a table. Again, same kinds of things to think about. Should the horizontal distance be the same? And it's yes, because it goes 1, 2, 3. All right, so horizontal is your x's. So yes, it should. Vertically, should it stay the same? Well, it goes from 5 to 4.8 to 4.6 to 4.4. And that is consistent. It goes down 0.2 each time. So yes, it should. So I'm looking for a graph that has consistent changes in x and consistent changes in y. All right? And then as I follow from left to right, the graph should be going down, because as I increase my x's, I'm decreasing my y's. So the graph should go down. All right? It's not this choice, because this choice doesn't have a consistent decrease. All right? And you know it's consistent when the graph is a line. If it's a linear graph, you'll know it's consistent. All right? And this one's not. B is not. All right? And then it gets a little tricky between A and C. Well, look at the end point here. This is telling me I'm at 0 in point 1, 2, 3, 4. Okay, in the fourth point. So day 0, or when x is 0, when x is 1, when x is 2, when x is 3, I'm at 0. But I shouldn't be. When x is 3, I should be at 4.4. So it's not choice A. The best choice is C. Okay? Consistent. It's a linear graph. When I get to that third point, I'm still above 0. So I like choice C. All right, last thing. Model rocket rises quickly, then slows to a stop as it burns fuel. It begins to fall quickly until the parachute opens, after which it falls slowly back to the Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. Okay, so at first it's going up quickly and then slowing to a stop. So going up quickly and then slowing to a stop. Well, first thing I do is label my graph. So time here, and then the height here. Okay, the height depends on the time, so the height should be on the y-axis. The time should be on the x-axis. All right, I'm going up fast, and then I'm slowing to a stop. All right, rises up quickly, then slows to a stop. Okay, so that's what my picture looks like right there. Goes up fast, slows to a stop. Okay, it's not going up anymore. All right, and then it starts to fall quickly. All right, so it's going to go down pretty quick. All right, it starts to go down. And then the parachute opens. All right, so once the parachute opens, then it keeps going down, but it starts to go down slower, and it goes down consistently down to the ground after my parachute opens, and it should look like that. Okay, so that's my interpretation there. Hopefully it's okay with you. All right, fall slowly there. That's it, my friends. That's section 4.1. If you draw me a picture of a lion on the top of your paper, I'll give you some extra credit. All right, I'll see you next time. Peace.